For thousands of years, the moon has been more than just a companion in the sky. It has been a clock, a compass, a symbol, a mystery. Ancient civilizations built monuments aligned with its path. Farmers planted crops by its cycle. Poets have filled entire lifetimes with words inspired by its glow. Even today, with all our technology, the moon still tugs at something deep within us. We glance up at it instinctively. We feel connected to it without fully understanding why. It feels powerful because in many ways it is. As the moon changes shape in the sky, from a razor-thin crescent to a glowing full orb, it feels as if something dramatic is happening. The transformation seems almost alive, like the moon is breathing through the phases of its own celestial life. These changes are so regular and so striking that people throughout history believed they must be influencing events on Earth. Everything from human emotions to the growth of plants to the behavior of animals. And in the modern era, a new question arises, one that sounds both scientific and slightly unsettling. Are these phases, these constant shifts in the moon's appearance, powerful enough to change Earth's orbit around the sun? At first glance, it seems possible. After all, the moon moves oceans, pulls at the crust of our planet, and subtly changes the length of our days. If it can reshape water and stone, could it also reshape Earth's cosmic path? To understand the truth, we must move beyond the glow, beyond the illusion, and into the physics that govern the Earth-Moon relationship. The phases of the moon might seem like physical transformations, but they are actually reflections, cosmic shadows, and light. The moon is always a sphere, always half-lit by the sun at any given moment. What changes is the angle between the sun, the Earth, and the moon. As the moon orbits our planet, we witness different portions of its sunlit half. Sometimes we see only the darkened side and call it the new moon. Sometimes we see the entire illuminated face and call it the full moon. Everything in between, crescents, quarters, gibbous shapes, are simply intermediate stages of illumination. This cycle repeats every 29.5 days, like clockwork. But despite how dramatic the phases appear, they don't change anything about the moon's gravitational influence on Earth. The moon's mass stays the same. Its distance from Earth remains nearly the same during each phase. Its orbit continues unchanged. In other words, the moon's phases are a visual effect, not a physical one. They are the moon under different lighting conditions, a celestial projection created by geometry and sunlight. And this distinction matters, because gravity, not light, determines orbits. The Earth's orbit around the sun depends on the gravitational forces acting upon it, and the phases of the moon simply do not alter that gravitational pull. The moon's tug on Earth remains constant no matter how bright or dim it appears in the sky. Phases may captivate our eyes, but gravity listens only to mass and distance. If the phases themselves are harmless illusions, the moon's gravitational pull is anything but. The moon exerts a constant force on Earth, drawing massive volumes of ocean water toward it. This creates two enormous tidal bulges, one facing the moon and another on the opposite side of the planet. These bulges are not stationary. As Earth rotates, they sweep around the globe, dragging enormous amounts of water across continents and shorelines. But tides do more than move water. They bend Earth's crust by a few centimeters. They stretch and relax the planet's rocky shell. They slow the rotation of Earth by transferring rotational energy outward. It is a subtle effect, almost imperceptible in a single day, but over millions of years, the consequences are profound. Days grow longer. The rotation of the planet gradually decelerates. Energy is moved through the Earth, Moon's system like a slow, quiet exchange of momentum. This transferred energy pushes the Moon outward, farther away from Earth, little by little. Today, the Moon drifts away at about 3.8 centimeters per year. Over billions of years, this slow retreat has transformed the way we experience time, light, and even the appearance of eclipses. At one point in Earth's distant past, the Moon loomed much larger in the sky. Total solar eclipses were more frequent and far more dramatic. But even though the Moon can reshape tides, alter our days, and move slowly outward in space, none of this, neither the tides nor the Moon's retreat, changes Earth's orbit around the Sun. The forces at work are real, powerful, and measurable, but they are internal to the Earth-Moon system. To change Earth's orbit, you need an enormous force, something capable of competing with the Sun's gravity. The Sun controls Earth's trajectory with overwhelming dominance. Its gravitational pull is so massive that even Jupiter, the largest planet in our solar system, can only make tiny perturbations to Earth's orbit. Against this cosmic backdrop, the Moon is relatively small. Its gravitational influence is strong enough to move tides and stabilize Earth's tilt, but not nearly strong enough to shift Earth's entire orbit around the Sun. More importantly, the Moon's gravity does not change during its phases. The phases are nothing more than changing angles of sunlight. They do not alter the Moon's mass. They do not redistribute weight. They do not pull harder or softer on Earth. In fact, if you could somehow turn off the Moon's phases entirely, if you could freeze the Moon in a single phase forever, Earth's orbit would remain completely unchanged. But what about tidal forces? Could the energy exchange between Earth and Moon impact Earth's motion around the Sun over millions of years? The answer is yes, but only in the smallest, most negligible way imaginable. The effect is so tiny that it cannot shift Earth's orbit in any meaningful sense. Instead, it only affects the relationship between Earth and the Moon, the length of the day, the distance between the two bodies, and the timing of tides. The phases, therefore, play no role. They are spectators, not participants, in the gravitational drama. Fast forward billions of years, and the Earth-Moon system continues to evolve. The Moon drifts farther away. Earth's rotation slows even more. A day might eventually stretch to more than 30 hours. And one day, distant far beyond human existence, the Moon will have receded so much that total eclipses will be impossible. The Moon will no longer perfectly block the Sun's disk. Eclipses will become mere rings of fire, annular, delicate, incomplete. But through all of these changes, Earth will continue orbiting the Sun along nearly the same elliptical path it follows today. The Moon can influence our oceans, our nights, and the length of our days. But the Sun remains the architect of Earth's orbit. Its gravity dominates the solar system, dictating the path of every planet, comet, and asteroid within its reach. Even as time reshapes our world, Earth's orbit will still belong to the Sun, not to the phases of the Moon. So the next time you look up at the Moon, whether it's a thin silver crescent dipping toward the horizon or a radiant full moon flooding the night with light, remember that what you see is a beautiful illusion of perspective. The Moon changes its face for us, but not its force. It influences our tides, our nights, our sense of time. It stabilizes our seasons and shapes the rhythm of life across the planet. It is a partner in Earth's story, a shaper of worlds, a silent force of nature. But altering Earth's orbit around the Sun? That is beyond its grasp. Some celestial forces glow with beauty, while others move the planets themselves. The Moon belongs to the first group. A stunning, powerful companion, but not a cosmic mover of worlds.